What if, one day, we could turn Mars into a second Earth? Picture this, a world where humans walk freely on a vibrant, blue planet, a world where the winds carry the scent of pine trees and the sky turns shades of orange and pink at sunset. Sounds like science fiction? Well, not entirely. Welcome to the fascinating concept of terraforming Mars. Today, we'll explore the science, challenges, and possibilities of transforming Mars into a habitable world. Can we really make this barren planet a place for humans to live? Let's take a deep dive into terraforming Mars and uncover the secrets of the red planet. What is terraforming? Terraforming is the process of transforming a planet's environment to make it more Earth-like. On Earth, we have breathable air, liquid water, and a climate that supports life. Mars, however, is a cold, desolate world with a thin atmosphere, no liquid water on its surface, and no magnetic field to protect it from solar radiation. The goal of terraforming is to change these conditions so that life can not only survive, but thrive. The challenges of terraforming Mars. The challenges are monumental. Mars is about 1.5 times farther from the Sun than Earth, which means it receives less warmth. Temperatures on Mars can drop to a bone-chilling -125 degrees Celsius, -195 degrees Fahrenheit, at the poles, and even at the equator, it barely climbs above freezing. But that's just the beginning. The Martian atmosphere is over 95% carbon dioxide, and it's less than 1% the thickness of Earth's atmosphere. Without a thicker, oxygen-rich atmosphere, humans would need spacesuits just to survive. And, perhaps most daunting of all, the lack of a global magnetic field. On Earth, our magnetic field protects us from harmful solar winds. Mars, however, lost its magnetic shield billions of years ago, leaving its atmosphere vulnerable to erosion by solar radiation. Step 1. Warming up Mars. To make Mars more Earth-like, the first step would be to warm it up. Without a thick atmosphere, Mars is an icy, frozen desert. One idea is to use greenhouse gases, like carbon dioxide and methane, to create a warming effect. These gases trap heat, making the planet's surface temperature rise. One proposed method is to deploy massive mirrors in space to reflect sunlight onto the Martian surface. These mirrors could concentrate solar energy and slowly warm the planet. Alternatively, we could send greenhouse gases to Mars, either by releasing them from the Martian soil or by using industrial processes to generate more. If the temperature were to rise significantly, it could melt the polar ice caps, releasing water vapor and thickening the atmosphere, a crucial step in creating a stable, livable climate. Step 2. Creating an atmosphere. The next step in the terraforming process would be to create a breathable atmosphere. On Earth, the atmosphere is made up of nitrogen, 78%, oxygen, 21%, and trace gases like carbon dioxide. Mars, however, has almost no oxygen and only a tiny amount of nitrogen. For humans to breathe without spacesuits, we'd need to add oxygen to the mix. But how do we do that? One possibility is to use algae or genetically modified bacteria. These organisms could survive in Mars' harsh conditions and slowly begin to convert carbon dioxide into oxygen through photosynthesis. Over thousands or even millions of years, this process could slowly build up the oxygen levels in the Martian atmosphere. In addition, we would need to thicken the atmosphere with nitrogen. Without enough pressure, the oxygen we introduce would simply evaporate into space. There are a few theories for how to achieve this, including the use of volcanic activity or artificial methods of producing nitrogen-rich gases. Step 3. Introducing water. Water is the key to life. And while Mars has large amounts of water trapped as ice beneath its surface, bringing that water to the surface is no easy task. One option is to melt the Martian ice caps by heating the planet's atmosphere, as we discussed earlier. As the ice melts, it could form lakes, rivers, and even oceans. But what if there's not enough water on Mars to sustain life? In that case, we might have to import water. Some researchers suggest that we could send asteroids or comets, rich in water, to Mars to increase its liquid reserves. These objects could impact the planet, delivering vast amounts of water to form seas and lakes. Over time, the process of evaporation and precipitation could help create a hydrological cycle, with water flowing across the Martian surface, just like on Earth. Step 4. Stabilizing the ecosystem. Once the atmosphere is thickened and liquid water is flowing across the surface, we would need to stabilize the ecosystem. That means introducing plants, trees, and eventually animals to the Martian landscape. Early on, we could start with hardy plants that can survive in low gravity and in the thin atmosphere. These plants would help produce oxygen, create soil, and provide food for later stages of terraforming. In the long term, a full-fledged ecosystem could develop, with forests, grasslands, and even oceans teeming with life. Of course, this would take centuries or millennia, but with each step, Mars would become a more Earth-like world. The ethical and practical considerations. But before we race to terraform Mars, we must consider the ethical and practical implications. First, is it right to change another planet's ecosystem, even if it's currently lifeless? Should we be focused on fixing our own planet before we start altering another one? There's also the question of scale. Terraforming Mars would require enormous resources, unprecedented technology, and a timescale of centuries or even millennia. It might take tens of thousands of years to make Mars truly livable, a time frame far beyond the lifetimes of most human generations. The future of Mars and beyond. So, is terraforming Mars possible? The science is still speculative, but it's not out of the realm of possibility. With the rapid advancement of technology and space exploration, we may one day be able to turn the red planet into a second home for humanity. But whether we can or should terraform Mars remains a question for future generations. Until then, we can only dream of what might be, a future where we're not just explorers of the cosmos, but pioneers in turning barren worlds into thriving, vibrant planets. The journey of terraforming Mars is not just a scientific endeavor, it's a vision of humanity's future among the stars.